Are you in a position to see my screen?
Yes, Abel.
So when you look at this question, they are telling us that a discrete random variable x has the following probability distribution. And part A, we are told to determine the value of m. How do you determine the value of m? This is what we are going to do. How do we determine the value of m? So let me open another workbook, okay? So this we are looking at probability. For question one, trial question one, how do we determine the value of m? Remember, this value of m, when you look at our question, this value of m, you are given probabilities here. You are given probabilities. When you're dealing with probabilities, always know that the sum of the total probability should be equal to 1. If you add all the probabilities given, the total probability should give you 1. Okay? So it means that you're going to use that idea that from the summation of the probability we normally use from the total probability which is equal to 1, or the summation of the probability is equal to 1. So if I add all my values, all my probabilities, do you have the question? You should be telling me. Do you have the question? What was the first probability? That is m. If I get m plus that is 4m plus what? Plus 5m. What do you get? You get 1. So you need m. You need the m. So what will be your m when you add m plus 2m plus 3m plus 4m plus 5m? What do you get? This is 1. 1 plus 2, that is 3 plus 3, that is 6. 10, that is 15. So you have here 15. 15m is equal to 1. So you need m. M is equal to what? 1 out of 15. So that's the part, that is Roman 1. Any question on Roman 1? That is our Roman 1. That is our Roman 1. Then next, Roman 2. Roman 2, we need what? When you look at the question, Roman 2, we are told to look for what? Roman 2, we are told to look for the model value. What is the model value? What is the model value? The model value. What is the model? What is the model value? Okay. So how do we get the model value? The one with the highest probability will be your model value. So when you look at the question, we have this table. So since we have that table and we are looking for the model value, we have our m. already we have our M. Remember, M is what? 1 out of 15. 1 out of 15. This is equal to what in decimal points? It is equal to what in decimal points?
It's 0.0664, 0.06.
0.06, like this, eh?
Yeah,
Okay. So we need to remove M and put the values. So if you substitute here, what will be the value? This is 0.06. 0.06. Then then here it will be what? It will be 2 times 0.06. And what do you get?
0.13.
You get 0.13, like this.
Yes,
Then
yes,
here what do you get? It will be here, it will be 3 times 0.06, and you get what?
0.19.
You get 0.1, 0.19, 0.19. Model value is the value with the highest probability. The value with the highest probability. And what is that value? What is the highest probability? What is the highest probability?
0.3.
Where you have a higher probability, it's here. So it means that our model value, so the model value, the one that gives you that probability, the model value is equal to what? 5. That is the model value. Is that hard? You know, some of you guys fear probability. Some of you just fear probability. Yet these things are not hard. But when you put it in your mind, it becomes very hard. So that is how we get the model value, or the mode. Okay? That's how we get the model value or the mode.
Excuse me,
Then next, yes, please.
Sorry to take you back. I'm asking, how did you get the first 0.06?
How we got
Under
this?
1, yes.
It is from Roman 1. From total probability, if we add all our probabilities, it should give you what? 1.
1.
So what are our probabilities? We have M plus 2M plus 3M plus 4M plus 5M. What do you get? You get
15.
15M, which will be equal to what? 1. So you need M. Divide both sides by what? By 15.
By 15.
So it is 1 out of 15, which gives you what? Let me hope it is 0.06 when you get 1 over 15.
Yes.
Roman 3. But I want to confirm that you can hear me.
We can, Abel.
Yes, can hear
Okay.
you.
So Roman 3, we are told to construct a cumulative probability function, or the table, and determine the median value. Even if the examiner had not told you to construct a cumulative probability table, And he had said, let's say, determine the median value. As a must, you always do this cumulative probability table. And how do we construct the cumulative probability table? It is very easy. The way you hear the word cumulative, you are accumulating the probabilities. You are summing up the probabilities. So Roman 3, sorry. Let me first copy from here. Let me first copy from here. And we are looking at this. We are looking at this. So how do I determine this? How do I, first of all, what gonna be my cumulative table? I first come up with a cumulative probability table. What will be my cumulative probability table? Or from your table, this one, from your table here, from this table, from this table. From this table, from this table, I can get what? I can get my cumulative. So I add another. This probability is like getting, this is like P into X is equal to small x. Sometimes they will always give you that. And also here, this is like your x. This is your random variable x. Okay, now we need the cumulative one. The cumulative. So I add another row. I add another row. So before I add another row, guys, where I say the total probability here, when you're revising and you meet something like this, don't be surprised. When you meet something like this, summation of, when you meet that, don't be surprised. That is the formula that we use to get these things. But of course, there is no difference. Someone who had said that the total probability is equal to 1, and someone who had used this, all of you, you're right. All of you, you're very right. Okay. So let's proceed. Now we need the cumulative probability. I need to accumulate. I need to aggregate the cumulative probability. The cumulative probability. How do I get the cumulative probability? You add. The starting point is 0.06. Then I keep on adding. I get 0.06. I add this one. What do you get? 0.06 plus this. What do you get? Are you on?
Yes, Abel, you get 0.197.
0. What?
197.
37 is coming from where?
I'm getting 0.19.
Then you add 0.09 plus 0.09. On your calculator, this figure, if you're to round off to 2 decimal points, please round off to 2 decimal points, make it 7. Because it cannot be 0.06. It is either 0.0, another person can say 0.067, like this, Like this. All of you, you're right, But if you use 2 decimal points, stick to 2 decimal points. If you use 3 decimal points, stick to 3 decimal points. Okay? So here, let's stick to 3 decimal points, maybe so here, when you get 2 times this, you get this one. 2 times this, you get this one.
0.134.
Then here, please be consistent. When you use
0.201.
0.201 like this. Then here,
0.268.
then here,
0.335.
let me hope you're rounding off. If a figure is a 5 something, make sure that you round off to, if it is 5 or above, make this one 6, make this one 9, depending on the figure you have on your calculator. So when you add, give you 1.
Yes, you have a 1.0. 1.005.
Okay. The issue is just on what? On decimal points, which is the this is 0. Okay, here the value is 5 because it is the one that has the highest probability. Okay, where are we? So I repeat, please, if you decide to use 2 decimal points, stick to 2 decimal points. Stick to 2 decimal points. If you decide to use 3 decimal points, stick to 3 decimal points. But in probability, we recommend 3 decimal points in probability. So what is the cumulative probability? We are just adding. So the first one is 0.0067. Then here, you add this one plus this. Someone who had asked, we get this one plus this. What do you get?
0.201.
Then add this one.
0.402.
Add this one.
0.938.
Then finally add the other one.
It's 0.67.
0.6
7.
only.
0.
Okay, then add this.
1.
Okay. At the end,
1.005.
1.005. Even if you put 1. At the end here, we should be having something like 1 at the end. Okay? If you are to round off to the whole number. Now, once you have your cumulative probabilities, this is your cumulative probability table. You're done. But the question is, what is the median value from your cumulative distribution, from your cumulative probability table. From our cumulative probability table, we can get the median. So look at your cumulative probabilities. Look at your as you determine probabilities, as you determine median. As you determine median, look at your cumulative probabilities. Then ask yourself, what is the first cumulative probability? What is the first cumulative probability that is above 0.5? The first probability which is above the first probability that is above 0.5 will help you to know the median. So look at your cumulative probabilities. Then ask yourself, what is the first cumulative probability that is above 0.5? Where you have the first cumulative probability that is above 0.5, we'll give you the median. Where do we have that figure? Where do we have that figure?
On 4.
On column 4.
On column 4. So our median will be equal. Our median value will be equal to 4. That will be our median. The median is the value of x that gives us the first cumulative probability, which is above 0.5. So you're done. You're done with your number. You're done with your number. You're done with your number. Any question? Are we at par? Are we together?
Yes, Ebo.
Okay. So next, we are to evaluate the probability. We are to evaluate or to determine the probability of this. Now, which probability do you need? You need a probability of x that is greater. If they say 1 less than x, it means that x is greater than 1. So you need the probability of x is equal to, now x is greater than 1. So you start from 2. Then add. Okay, what do you find between 1 and 4? What are those values? What are those values between 1 and 4? 1 is not inclusive, even 4 is not inclusive. So what are those values? You have 2 and what?
3.
You have 2 and 3, isn't it? You have 2 and 3. Let me hope you're okay. Then you just substitute. What is the probability of x is equal to 2? The probability of x is equal to 2. This is 2. What is the probability of x is equal to 2? This is our probability. This is our probability. Then what is the probability of x is equal to 3? This is the probability. So get this one 0.31314. Then plus the other one is what? Plus the other one of 0.201. And what do you get? Or what do you get?
It's 0.134. No, I'm saying like the figure you wrote.
We get
Pardon?
0.515.
The figure of 0.315. Yes.
Okay, so when you get probability of x is equal to 2 plus this, what do you get?
0.335.
And that is your Roman 4, you are done. Then next, Roman 5. Roman 5 is about what? The probability of what? Roman 5, you need the
Excuse me again.
probability of this. Okay, sorry. The question was what? How do we get these values?
Yes.
Remember, you have the values of x. These are values of x. X is equal to 1. What is the probability of x is equal to 2? What is the probability of x is equal to 2? The probability of x is equal to 2. These are probabilities. So the probability of x is equal to 2 is this one. Then the probability of x is equal to 3. It is this one. So we are getting this. That's what you see here. Then plus the probability of x is equal to 3, which is this one. Is it okay now?
Yes, thank you.
Okay. Then here, what do you get? Here you're looking at which values. 1 is inclusive and also what? 4 is inclusive. So it means that here you will start from probability of x is equal to what? 1. 1 is inclusive. When they put this, 1 is inclusive. Then plus the probability of x is equal to 2 plus the probability of x is equal to 3, then plus the probability of x is equal to 4. So simply add. What is the probability of x is equal to 1? The probability of x is equal to 1. It is this one. Can you hear me?
Yes.
Yes.
Probability. Then plus, I just copy these ones because I already have. I just copy. Then plus, what is the probability of x is equal to 4? Probability of x is equal to 4 is this one. Okay, so when you add, what is the total?
0.67.
0.67. Okay, that's about Roman 5. That's all about Roman 5. Then next, the last one will calculate the mean. Calculate the mean and the standard deviation. Now, when you're calculating the mean and standard deviation, mean is equal to expected mean. Also, these are free marks. This is Roman what? Roman 6. We need mean. How do we get mean? Mean is like expected. Sometimes you'll find that they are saying you look for expected value of x. That is mean. And the mean is equal to what? You get the summation. You get the summation. You get the summation. You get the summation. Summation x times the probabilities of x is equal to small x. That's how you're going to get mean. You have these things in the handout. When you check, you will be seeing the formula like this. But in simple terms, here what you do, just you have your table here. You have your table. You have your table ready. So from my table, what I'm going to do, these are values of x. These are x. This is x. But guys, don't forget. Okay. These are values of x. Then this is the probability. This is the probability. I can decide to remove this one so that I remain with only the probability. I want to remain with only the probabilities. I want to remain with only the probabilities. So this is my table. So do you see the formula? It is x times the these are probabilities. So this is like x time. This is just the probability. So I need the mean. So I can add another row. I can add another row and I call it xp, x into, okay, x times the probabilities. I bring this one, x times the probabilities. I bring this one here. So you're getting this times the probability. 1 times the probability you get. For this one, you get 0.67. Then 2 times this one, what do you get? 2 times this. You're getting x times the probability based on our formula. This time this, what do you get?
0.268.
Then 3 times this.
0.603.
Then 4 times this.
1.072.
1.072,
0.2, yes.
Then here.
1.675.
So we need the summation, the total. What is the summation? What is the total? When you add, what do you get? When you add these values, when I get 0. Now in an exam, don't do that. It's just for you add on your calculator. Simply add those values and tell me the figure. What is the figure?
I'm getting 3.685.
3.6.
85.
3.6 85. That is your mean. That is your mean. Is that hard for you? Is that hard? Then standard deviation. Standard deviation is square root of variance. But how do we get variance? This is square root of variance. So how do we get variance? But variance is equal to, when you're getting this, it is this one. Then do we have expectation of mean from this question? From this question already we have the mean. The mean is this one. Sorry. The mean is this. Then the mean is this one. Then we substitute in the formula to get the variance. Substitute in this formula to get the variance. Substitute in this formula to get the variance. So mean variance will be, it will be what? Someone's tell me it will be this figure because already you have it. Then minus the mean squared. This is mean squared. So you get this value, you square it. Are you making that adjustment? You square it. Then the overall answer, what do you get?
1.4958.
Round off 3 decimal points. 1.49.
6.
Okay, so that is your variance. After getting variance, get standard deviation. And the standard deviation is the square root of variance. So when you take square root of that figure, what do you get?
$1.223.
Pardon?
1.223.
Properties of variance. Now, if it is variance of a constant is 0. It is not like variance of a we say that the expectation of a constant is a constant. But when it comes to variance of a constant like 3, if you are looking for variance of 3, variance of 10, variance of 100, you get 0. You get? So variance of a constant is equal to 0. That is rule number 1. Then if you're looking for variance of something like this, for example, like a variance of 6x. So variance of 6x is equal to what? Looking at our rule, variance of x, ax, a is a constant, like 6. So you put 6 outside and square it. You note the difference. You put that 6 outside and square it, then times the variance of x, which is different from mean. If it is something like this, you put the constant outside, don't square it. Don't square it. Okay, then times the expectation of x. So you note the difference. So that here, when you're dealing with mean, you put the constant outside, then square it, then times the variance of x. Okay, then the properties of, then the rule number 3, like this one, I believe now it will be easy for you. When you look at this, open bracket, when you open bracket, you get this plus this. But variance of a constant is 0. That's why you have 0 here. Then you put a outside but square it. So when you're looking for variance of 3x plus 8, you first open bracket, that is variance of 3x plus variance of 8. But variance of 8 is a constant. Variance of a constant is 0. Then here I put 3 outside, but I square it. Then times variance of x. In the question, we are given variance of x. Any question? Any question? Okay. These are some of our questions. So when you look at, let's say, August 2024, question 1, if we open our paper, August 2020 what? August, you guys don't hate the topic completely. At least master something on that topic. Don't hate the topic completely, and for you, you say, me with this, I can't. No, try to master something small on that topic. You never know. What you have mastered can appear in your paper. August 2024, 2024. So when you look at this, August 2020 what? August 2024. Now you see how these things are easy. So like for you, you say I can't do probability, but you reach an exam and find that you have these marks. So let's see. Can you do this? Okay. How do you get K? How do you get K?
Using rule 1 of probability, which says that all probability is equals to 1.
From total probability? From total probability, which is equal to 1. Or you're getting this one, the one that we had, this one, from this one. So get, can you handle add these figures? Get to 0.2 plus, it may look to be, someone tell me 0.3 plus what? I don't know whether you have the question. It is 0.2 plus what? 0.3 plus, you first write 0. 0.2 plus 3k plus 0.1 plus 2k plus k squared plus 7k squared plus 2k squared plus k is equal to 1. So, add the squared separately, add the k, the ones with only k separately, add the ones without k separately. So get 0.2 plus 0.1, that one you get what? 0.3. So I have 0.3 here. When I get 0.2 plus 0.1, then I add the one where I have only k. 3k plus 2k, that is 5k. Then plus this k, that is 6k. I am collecting like terms together. This is 6, this is 6k. But you hear someone saying now it is becoming hard. This is 6k. Then we are collecting like terms. K squared plus 7k squared, that is 8k squared, plus 2k squared, that is 10k, 10k. This is 10k. This is 10k squared. 10k squared. Then we equate everything to what? To 1. But you need k. you need k. So if you rearrange, that will be like 10k squared, 10k squared. If you rearrange, this is what you get, then minus 1 is equal to 0. Because here it is a quadratic equation. So what do you get? But are you guys following? What do you get here? 0.3 minus 1, what do you get? Minus what? 0.7 is equal to 1. Let me hope now you can get the value of k when you have this. Can you? How can you get Rosemary? Shira, how do you get k when you're on this step? Vivian, how do you get k?
Do we use the
We use
bulldozer?
You use the bulldozer. Yes, you use a bulldozer, then you take k. You will conclude with k that has a positive value, because probability cannot be negative. So you conclude with k, which has a positive value. So that's how you are supposed
Where are you
to
getting the
approach that.
0.7?
How am I getting? Remember, this is from this step. Here, are you okay?
Yes.
Now we
Even the
rearrange.
second one, I'm okay.
Even here, you
But
are
the third
okay.
one.
When you get 0.3 minus 1, what do you get?
Oh, yes, I've gotten it. Thank
Yeah,
you.
I'm not okay with the 0.3. Where did it come from? Because it's not in the question.
Pardon?
The 0.3. Like, where did it come from? Because it's not in the question.
Auntie, you see, we started with this one. First, write this. First, get 0.2 plus 3k plus 0.1 plus 2k plus k squared plus k plus 7k squared plus 2k squared plus k. First, write that. Then you equate it to 1. After that, correct like terms. After that, correct like terms. Correcting like terms means what? You first deal with values that don't have k. So you'll be having this plus this, because those are the only values without k. And if you get 0.2 plus 0.1, you get what? You get 0.3. Are you okay now?
Yes, thank you.
Then the other ones get this, add this, then also add this one. 3k plus 2k plus k. You get what? 6k. Then after that, deal with k squared, where you have k squared. You collect like terms. Okay, I believe after that, you will be in a position to get. How do you answer this? What do you need? Here, examiner is telling you to focus on which values. Someone's telling probability of x is equal to what?
Probability of 3, 4, and 5.
2 is not inclusive. 2 is not inclusive. So it is probability of x is equal to 3 plus, probability of x is equal to 4. 5 is included. Then plus probability of x is equal to 5. You will be having the probabilities, because after getting k, you substitute and get the probabilities for each value of x. Then to get variance, I believe now you are okay. To get variance, it is expectation of x squared minus mean squared. So to get variance, to get that variance, you will apply this. You will apply this approach, but of course you will have. It would be better for you. You add another. You do everything at once. You do like this. You first have this. You first have this, because it will help you to get mean. Like this. This one helps you to get mean. You do everything. You first lay the table like this. Put values of x, put the probabilities, put this one. This one is going to help you to get mean. Then which one is going to help you to get expectation of x squared? You need x squared, then after get this. After that, then you substitute in your formula. Be adding the values. You add these values to get e squared, expectation of x squared. Then you add these values that you'll be having here to get mean and substitute. I believe that one was friendly. Please, I repeat, if you can raise 8 marks on a number, please do that number in your exam. Please do that number. Please do that number. Don't be scared about other things that now, for you get those 8 marks, you never know, you can get another number where you score above 10. When you look at December 2022, question 2, December 2022, December 2022, question 2. And this is question 2. December. Part A, we are going to discuss it in the next discussion about, that is about normal distribution. Normal distribution and binomial distribution, then plus Poisson. It was a good number, but I'm interested in part B. Are you seeing those free 6 marks? By the way, isn't it the same? It's like the other August, what? August 2020. It's like the other August 2024. Almost the same. 1k plus 2k, that is 3 plus 2k, that is 3k plus 2, that is 5 plus 3, that is 8. 8k. 8k plus 1, that is 9k. So you have 9k. You will have 0 plus 9k plus what? Plus k squared plus 2k squared. That is 3k squared plus 7, that is 10k squared. So in this question, you have something like this. You have something like this, 0 plus the other case where how many cases? If you add k 3, 5, 8, 9, isn't it 9? 9k. 9k. Then plus what? Plus 10.
9k squared.
Plus 10k. Plus 10k squared. Plus 10k squared. Then you equate this one to what? To 1. Because you are summing up. Then you rearrange, that will be like 10k squared. 10k squared. Then plus 9. 10k squared plus 9k, then minus 1 is equal to 0. Because here you need it to work as it is 0 minus 1, which is negative 1. So once you reach here, you use your Bredolin method. Okay. Those marks are free marks, guys. Then here, what do you need? It is from 4 to what? 4 to 6. The value is between 3 and 7. I was interested in that. Part A, actually, we are going to start. This one is on you. I will not discuss it. I will not discuss it. Please go and listen. Listen to those, because now I will be repeating myself instead of doing other numbers. This one is there. You listen, plus this. You listen to those things. Now you will be using other questions. Yes, discussing the same topic, but using other questions. September 2022. September 2022, what is it all about? I want to show you that you can raise those marks. And don't joke with 6 marks, 8 marks, 5 marks, even 1 mark, 2 marks. It means a lot in these professional papers. In these professional papers, especially where you see you want to score like 5 and above. 5 marks means a lot, from 45 to 50. So September 2022. Is it September? Let me see. Question 5. Question 5. Are you seeing these 5 marks? Are you seeing these 5 marks? Can you fail? Can you fail to raise the... These ones are just 3 marks. Any question? I think that's enough for now.